This presentation is by Dr. HongTae Kang, and it's work that he's been doing with collaboration with General Motors. Dr. Kang earned his PhD at the University of Alabama, working on the fatigue of joints. He is currently the an associate professor at the University of Michigan-Dearborn. And today we welcome Dr. Kang, where he's going to discuss a modification method used for the SN curve of spot welded joints. Thank you.
Thank you for introductions. Hi, good morning. This morning I will talk about a little bit on a method for modification of SN curve for especially for short fatigue life regions. Okay. Basically, this main idea is from AK from GM. And so he asked me, so I just did it. So I'm not, I don't know much about it, but he knows. If you have a question, I will give him an opportunity to answer it too. All right, so I'll talk about why we try with this simple modification method, and then what type of material data we used it for prove these ideas it works, and then actually introduced how that method works, and then how using that method we will provide what is difference before and after, and then we will summarize that talks. This is the structure stress method. We just using it is using what linear elastic FA approaches, right? Linear elastic approach. We either the spot weld is represented with the C bar or ACM. What kind of the FA method you're using? That is mostly we are using. So basically, that joint is under small loading, low loading, that we may experience the plastic deformations. But in the FPA we are using, and it cannot be represented that behavior. And then actually we do testing on the coupons. We will see it actually that deformation, initial deformation is actually a lot. So linear, not really that much linear elastic at all. So because of that reason, we thought about how we representing that initial changes of material behavior into FPA model. So that is basically the purpose of this works. Right? To study on that thing, we look at it some steel specimens. That is DP 800 martensitic steel 1300, and then also DKSK we look at it, and then all thickness, sheet thickness, we only look at 1.6 millimeters, and specimen type we had the tensile shear and Coachfield specimen. Used it. This is a typical load displacement curve for the tensile shear specimens. Okay, so Coachfield is about the same, but the load is because very low. Is it? I don't know. You see it. So in this way here, I don't know. This is the initial very much linear, but what we do is fatigue testing at this load level, and do fatigue testing, correcting data on this load level, correcting data. In that way, we do creating SN curve. But thing is about what will be happening at this load. So linear elastic goes is straight up here. We can consider it at this load level. See here, and actually that displacement and load in the linear elastic and this point is different. So we have to convert that one. That is the main process we're doing. So this is the fatigue testing procedures, the 5 hertz and to 30 hertz. So we used it, and then this load ratio and definition is a fully separation, and this is a runout cycle, and that all test condition and a full test result is very well documented in this reference in 2006 from ASP project. This is the data at that time we obtained. This is tensile shear, and this is coach fill. So that is only the material we actually looking at it. Okay, so this is the material we're looking at it. So we're trying to looking at actually this region of fatigue, whether this is really good, well representing actual case, or we need to modification. So we're trying to focusing on this area to modifying the SN curves. Okay, so basically structure stress method, we use the root method, which is the ENCODE using it that I believe. It's slight difference there, but it's a basic approach is the same. So we use that one, and the reason is we have a design life, so it'll be a lot easier. I think you're using whatever structure stress method you're using, basically the same approach on that modification SN curve works. So we did it, we applied a shell, a beam and shell, but we used it actually SIBA element, and also we used ACM too, but stress level a little bit different, but still the same behavior. So with both method is all okay, right? And then, yeah, that is all things I probably already know. You work with spar welding fatigue issue, so it's exactly followed that guideline, what software asking. And then, so as I said, it's because the material is no longer linear elastic behavior, so we have to correcting that. The only way to do is whether you FA analysis do it non-linear approaches, non-linear or elastoplastic FA approach, you can capture some of that, but it's because full structures analysis, we are not using it. So instead of modifying that FEA approach, it's just that we correcting as SN curves, material data, that will be a lot simpler. So that is what this one we approach it, okay? So it's the same thing. I was just describing basic idea of transferring nonlinear relationship in experiment data into linear one in FPA. We're using some energy method. What is energy method? It means load displacement curve under certain point of the load we are interested in, that below that curves, the area for actual testing curve and the actual linear elastic FA curve supposed to be giving same area, that is the same energy, right? So then that is transferring that load to the other side, and that is the creating as a modification of SN curve point. So I will explain that thing here. So that is here. This is the curve, the testing curve. This is the linear elastic behavior curve. So what it does, actually testing data is giving in here. So this is load. This is, for example, say, I don't know, it's about 18,000 Newton of load applied in the testing actually going on the loading here, right? This is going on here. You got life of 1,000 cycle, for example. So you got it that one. Whether that 1,000 cycle loading is in FEA representation is whether that is right or not. That is the question. So what we believe is that is probably not right, because this is already plastic behavior in it, so that which is not cannot capturing in the linear elastic FEA. So instead of doing the same amount of load on here, just we have to move it here. In FEA analysis, actually you have to apply 21 Newton, 21,000 Newton apply. That will be corresponding 1,000 cycle of fatigue life, which is corresponding only here. So that will be moving it here. So SN curve basically has to re-plot it in this way. Yeah, this way. So basically, initially was before, and this is structural stress. But this one is initially we got it, whatever the test result, test the load, test load over here, and we got structure stress. That structure stress is corresponding to life, and that way we created SN curve. So when modification is not, this testing load was here, but actually in calculating structure stress, we have to apply higher load based on this approach, same energy, and that way we corresponding changing that load. So that is all have here. So the value of your this y part, so this is 100 or whatever that is actually this intercept value is changing. So if we're doing this way, and we can also avoid some static failures. Initially, you will have so many. Actually, there is not really static failures happening, but based on traditional way you do it, you have a lot of static failure you will have. So with this correction method, we're trying to avoid that issue. And then also this will make more sense comparing to real cases, right? So of course, the people may have said, we are not really looking at this area of life. We're mostly looking at this area. That's true, but this is one way to modifying correcting your SN curve. So that is the basic idea of what we did in here, this testing, this analysis. So this one is actually very true. I didn't really look at it a little bit more on this one. When we're trying to think about, I discussed with Juming Su, is here in the board, and that he also talked about these issues. Actually, I do not know. I didn't really fully complete the study yet. So simple spot welding specimen, you do tensile testing using AHSS or whatever software you're using, or load displacement curve, or you're testing an FEA not easily matching. Actually, frankly speaking, I cannot get it. That's very different. So that is maybe another reason you applying this method, it will be helping a lot, correcting. But we have to find out why it's not a matching, that I have to find it out. But even that is not matching or not, this method can give some correction on that problem. Oops. So that's my conclusion talk, and that is something we already discussed about it. So if you have any question, thank you.